All right, welcome to video 3. This is going to be soil composition and properties. Now, the properties of soil we'll look at are physical first. So this is basically where you're looking at the size and the weight of the particles. Notice the sand particle is very large, silt is a little bit smaller, and clay is very small. So if you guys remember when we did our own soil profile, where we took the soil and mixed it with water and let it settle, we were able to see the sand, the silt, and the clay. Might have been a little bit difficult to see some of these layers, but in most, not every soil is going to have a nice even distribution. We've used the soil texture chart just as a reminder in case you've forgotten. You do have to use this on the exam, AP exam, and the test for this unit. Essentially, when you notice, I wonder if it'll let me zoom. Nope. This will let me zoom though. Hey, look at that. So if you notice on the side of this, there are these lines that come through this way. So 80%, and there's this little line that comes through. That is what tells you that this is the direction you would go for the clay percentage. So if I had a clay percentage of 70%, I would find that little line and draw a direct horizontal line across. Then I would do my silt percentages. Notice this comes out this way, so I'm going to go down and to the left. And the last one would be the sand percentage. There's a line coming through here, so this would go this way. The other way to remember it is they kind of go in a clockwise direction. So you would go this way, down there, and that way. Hopefully it's not incredibly difficult to understand. I know it can be confusing. Just practice it, and I'll probably remind you before we take the test for this unit. More physical properties, permeability. If you recall, permeability is just the ability for water to infiltrate. Sand has the highest permeability, while clay has the least amount of permeability. For example, here, if you had some water and dropped it into gravel, that would take about 2 minutes to get all the water out. Sand would take about 2 hours, silt would take about 200 days, and then clay would take about 200 years. Clay is very impermeable. Water has a hard time getting into the clay and then moving through it. Because of that property, most landfills are lined with clay. And in the next unit, we're going to design our own landfill, and you're going to probably think about what would I want to line my landfill with. Probably not a bad idea to use clay, because clay doesn't allow a lot of the leachate, the liquid waste, to get through it and into the soil beneath. So this is just another example showing you of a landfill that's being prepped. Now, porosity and permeability are also important, along with fertility. A lot of this is determined by the particle size and the composition of the soil horizons. Clay can hold a lot more water, but it's slow to absorb it and slow to release it. It'll hold it, but it doesn't release it very quickly, and it takes a while for it to fill it up. You don't want to apply the water to a clay soil faster than it can soak it in. So here in northern Nevada, we do have a higher clay content in our soil, which means you don't really want to water for too long because you need to let it settle. Sand is very porous. Sand can allow quick water flow. If you're watering your grass, for instance, you'd want to water in half-inch increments to saturate 6 to 8 inches deep. If you like to garden and you like to do these kinds of things, you typically want to create your own soil. Sand is highly used in a lot of grasses because it allows for the water to permeate, to get a little bit further in, and allows the roots to expand a little more. A loam material, remember loam is typically the favorite when we're talking about soils for plants. It's porous, it retains the moisture because it contains sand, silt, and clay in a good mixture. Now, chemical properties, oh man, we're going to get into some chemistry here. Essentially, we're looking at how well the soil can hold different types of ions, right? So different minerals, essentially, for what we're talking about, like phosphorus and nitrogen. These are going to be important parts of soil. A clay soil is very acidic. it can have organic material. These are going to be higher in their ability to hold more nutrients. So just to get an idea, remember that essentially you're looking for the ability for the soil to hold those different ions so that then they can be taken in by the roots of a plant. So when we talk about base saturation, that's another point. This is just the proportion of bases to acids as a percentage. So remember that in most soils, our bases are going to be calcium, potassium, magnesium, and sodium, typically hydroxide, right? The acids are typically going to be aluminum and hydrogen. Now, when you want your soil pH and your base saturation, you want them to be roughly in the middle for a good soil, but this just gives you an idea and how to use this type of graph. This is going to be different based on the type of soil you're dealing with and its ability to hold bases and acids. The final type of property that we're going to look at are biological properties. These are important because your biological properties allow for these types of nutrients to be recycled. If you recall, decomposing detrivores, these are what are going to recycle that material and break down a lot of the other material. So fungi and bacteria and protozoans are typically 80 to 90% of the living things that exist inside of a soil, but you can also look at rodents, earthworms, snails, slugs, and what they're going to do is mix and break down that material. And the last little bit is the bacteria that can fixate the nitrogen. If you remember, nitrogen fixation is a very important part of converting nitrogen into a form that it can be used by the plants. So this is just a food web to show you what eats what, in theory, in a soil, right? So plants, typically, their energy is going to go to organic material, which is waste. That can be broken down by bacteria or fungi. Those will be broken down by root feeders like nematodes and arthropods. But you get an idea just following this process as these are broken down and allow for the food web to exist. They are part of the food web just as much as anything else, and they're just a smaller part. Now, you can test all three of these properties in a soil, and when you do that, it's going to just help you determine what kinds of things you need to do to your soil. Do I need to water it more? Do I need to water it less? Do I need fertilizer? These are all properties that need to be tested so that you understand how to treat your soil so that you get the best growth possible. And we did some of these soil tests in class with our soil testing lab. So that's going to bring us to the end of this video, and the next video will be all about the Earth's atmosphere.